today, what we're going to look at is yesterday we looked at how triangles aren't all about the side lengths. Okay, there's also other pieces to a triangle, specifically the angles, which we saw, right? And there's 3 angles inside of a triangle, and we saw how to label those yesterday too, right? We had like theta and phi and all these different Greek letters, right? And I said yesterday the 2 that I would use predominantly the most would be theta and phi, which are the 2 that I drew there. Okay. The other way to label like theta here, that's just angle A, right? It's just another way to write angle A without having to write 2 things instead of 1, okay? And we saw yesterday that the angle plays a role in the way that the triangle looks, but it's also very connected to the side lengths, right? Specifically the ratio of the side lengths, right? And remember the ratio, the word ratio means fraction. Okay, so with all that in mind, okay, this question here just wants you to solve for angle A, which is down here, right? Angle A, which I've said is theta. So what we learned yesterday was we had this thing called tangent, right? Tangent. And tangent was always, like if I wrote the tan of theta, tan theta was always rise over run, right? But we were trying to relate it to lines, okay? Rise over run is the slope, right? But yesterday we said, okay, we're going to do away with this rise over run notion for triangles. Rise was like how tall the triangle is, right? Well, in this question, it's 24. And then we said, okay, well, the run is how long it is. Well, that's 32. Okay. And then we said, okay, well, we don't really need this rise and run terminology anymore because we're not necessarily dealing with lines, we're dealing with triangles, right? But we made the association with 2 new terms, right? So if I'm standing here at angle A, right at theta, and I look across, I see the side length opposite of me, right? And if I'm standing at theta, right beside me, or adjacent, is what we call adjacent. Okay, so we developed this rule yesterday where it was tan theta is equal to opposite over adjacent. Okay. Now, that doesn't answer any questions, right? We're setting up a ratio. Ultimately, what we want to figure out, what this question is asking us for, is solve for angle A. Okay, well, we've kind of done half the work here. Okay, setting this thing up, and specifically labeling the side lengths as either opposite or adjacent. That's what we did yesterday. Okay. What I want to reinforce today, we did one question yesterday, but what I want to, like, the whole point of this is being able to solve for angle A. Well, we need to figure out, just rewriting here, okay, 24 over 32. Anytime you see something like this, you can just type that in your calculator and get a number, right? So let's do that. I gotta open up my calculator. I don't know why I always close it, but okay. So if I type in my calculator, if I go 24 divided by 32, I'm gonna get a number, right? Because I can type that in, 0.75. All right, so that means tan theta now. All right, so have we actually solved for angle A? Does it make sense that angle A would be a decimal number like this? I don't really think so, right? So I'm like, okay, my answer doesn't really seem to make sense in context, right? So the chances are either you've done something horribly wrong or you have a little bit more work to do, okay? And it's yesterday that we said, okay, well, I'm interested in angle A. Well, I haven't solved for angle A. I've solved for tan theta. the thing that I'm interested in is just theta by itself, right? So you're gonna say to yourself, okay, well, if it's how do I just get theta by itself? This is like your way of getting theta by itself.